All right, everyone, this is Zahid Bashir. I am a faculty member in Department of Commerce, University of Gujarat, and I am a PhD scholar at Delhi College of Commerce, University of Punjab. So today we are going to discuss the condition where T is less than 25 and N is greater than 25. It means your number of individuals or number of companies or number of countries would be greater than your time dimension. On the other way, we can say that time dimension would be less than your cross-sectional dimension. So in that case, we are going to consider the dynamic panel data analysis, where we are going to use GMM if endogeneity exists. So first of all, you need to understand the specific detail of dynamic panel data analysis. So the basic condition that you need to understand about dynamic panel data analysis is that the number of time period would be less than the number of cross sections. Cross sections means number of countries, number of companies, number of individuals. So today we are going to discuss this case. So in detail, I would like to discuss with you dynamic panel data modeling. Basically, this is dynamic panel data modeling where we discuss a lot of things regarding uh, the n less than 25 sorry, n greater than 25 and t less than 25. So the basic consideration that you need to understand, I will share with you some important paper regarding the dynamic panel data estimations. So here is a paper like fixed effect versus random effect assumptions along with system GMM. But before discussing the system GMM, you need to understand what is dynamic panel data analysis is and how we can deal with it. So let's have a look on a basic paper on how to consider the dynamic panel data analysis. So let me explain this one. This is a very good paper, very easy written paper on dynamic panel data analysis. Determinants of dividend payout decisions, a dynamic panel data analysis of Turkish Stock Exchange. So we are moving towards the dynamic panel data analysis. Previously, we were discussing the static panel data analysis, where we have discussed the fixed effect, random effect, pooled OLS, panel ARDL, and so on, some other models. So today we are going to discuss the dynamic panel data analysis, where n is greater than t. So always remember that whenever you have n greater than 25 and t is less than 25, you are going to apply the dynamic panel data analysis. So if you see in this paper, they have applied the dynamic panel regression, the dynamic panel regression on 853 observations. So observation is not important here. We need to understand the number of companies or number of countries here. So basically the number of countries here is 106, which is greater than 25. And the time period is less than 25. So if you see the number of companies and number of time period, the time period starts from 2009 and ends on 2006. So if I simplified this thing, we have n is equal to 106. It means number of companies. And we have t is equal to, if the data starts on 2009 and end on 2015, it's mean 6-year data. So if you see here, the n is greater than t. this is the basic consideration towards the dynamic panel, that your n should be greater than 25. The the second consideration that you need to understand is that n should be greater than 25 and t should be less than 25. So the first condition is that n should be greater than t, and n should be greater than 25 and t should be less than 25. These are the basic consideration that you need to understand, because in our case, the time period is only 6 year, which is t is equal to 6, and number of companies is 106, which is n is equal to 106. So n here is greater than 25 and t here is less than 25. So this is the basic condition that you need to understand for applying the dynamic panel data analysis. So it means that we are fulfilling the basic condition of dynamic panel data analysis. So what they have discussed here, according to results from Arlino Bower Belander Bond two-step system GMM method, a statistically significant positive effect on dividend payout was found in relationship between the dividend payout of the previous. So you need to understand that your dependent variable may be affected by its own previous value. So if I would simplify this basic consideration, let me show you from here so that you need to understand what is the basic consideration here. So let me show you a basic model. Let it be y is equal to alpha plus beta 1 x 1 plus beta 2 x 2 plus error term. So let's suppose this is our basic model. Now, if we include subscript IT here, it will become the panel data model. If we do not include the subscript IT, it would be a pooled model. So let's include the subscript IT with every variable, whether it is dependent or whether it is independent. Now it becomes a simple panel data model. So what is the difference between simple panel data model and dynamic panel data model? In dynamic panel data model, your dependent variable not only influenced by the independent variable like x1 and x2, it is also influenced by its own previous value. So let me show you another model which would become the dynamic panel data model. Let's suppose this is this is basically the model. I would like to include here. Let me show you another model here. YIT T minus 1 and uh, include here another term for calculating its variation. For example, if I would like to go here and I would like to find here another estimator, let me show you from another symbol. For example, this one. Now, just like beta 1, beta 2, which is basically measuring the impact of x1 and x2, this sign is basically measuring the impact of YIT minus 1. So YIT minus 1 means the previous value of your dependent variable. So whenever you convert the model like this, where the previous value of your dependent variable will become the independent variable in the model. It becomes the dynamic panel data model. So this is basically the dynamic panel data models. So the previous one was the, let me call it simple panel data or sometimes static panel data. So this is the basic difference between static panel data model and dynamic panel data model. In static panel data model, there is a simple model with subscript ID. While in case of dynamic panel data model, your dependent variable is simply influenced by its own previous value, while considering the other variable itself. So this becomes the dynamic panel data model. So if you see here, this says that a statistically significant positive effect on the dividend payout was found in relationship between the dividend payout of the previous year. So dependent variable is dividend payout here, and it is also affected by its own previous value. That is why they are considering it as a dynamic panel data model. So you need to come on the methodology section here in order to understand how they have applied the dynamic panel data model. First of all, you need to understand that the data uh, was extracted between 2009 to 2015. It's mean it is a 6-year data. So I would place here T is equal to 6, which is less than 25. So the another thing is that they have considered the number of companies here greater than 25. So might be they have mentioned here, they have mentioned how many companies. This is 853 is basically the number of observation. So they have mentioned here 106 companies. So basically, n is equal to 106, which is greater than 25. These are the basic consideration that you need to consider for applying or considering dynamic panel data analysis. So the next thing that you need to understand is how the process was applied. So this is basically the model. If you see here in this model, you can see here the dependent variable, which is dividend payout ratio, and it is also influenced by its own previous value. So if you can see that dependent variable is influenced by its own previous value, now it becomes the dynamic panel data model, while these are the usual independent variable they have used. And they have considered beta 1 as a first beta to consider the previous value of the dependent variable. So these are the independent variable in your model like this, and this is your error term. So the dependent variable is DPS, and they have mentioned, might be they have mentioned here in the above equation model in which a lag dependent variable DPS IT minus 1 is included as an independent variable are called dynamic model. So if you need to write a definition that what does it mean by dynamic panel data model, a model where the lag dependent variable of the dependent variable is included as an independent variable is known as dynamic panel data model. So let me write here a panel data model where the lag lagged DV lag dependent variable is included as the independent variable in the model is known as dynamic panel data model. So this is a very simple definition, and you can provide the reference like Gungor and Cajun 2015. This is the reference of providing this definition. So the next thing that you need to understand is that this lag dependent variable would be would be basically correlated with the error term. Always remember that the thing that make it biased is basically the correlation between the lag dependent variable and error term. I will let you know how this procedure works. So the next thing that you need to understand here is that this dependent variable lag would be correlated with error term. So if I would like to show you here the shapes, and this one would be basically required. Let me connect from here. Let me put it another way, like shapes, like this. So let's suppose this is how it is connected. So the lag dependent variable would be significantly correlated with the error term. This is another assumption that you need to understand for applying the estimation method, which is known as GML. And this condition is also known as endogeneity. So if you need to understand the concept of endogeneity in case of dynamic panel data, there is a concept which is known as endogeneity. So what does it mean? When your independent variable is significantly correlated, whether in positive way or whether it is in negative way, with error term. This scenario is known as endogeneity. So if you see here, your dependent variable has become the independent variable here, but we assume that this independent variable is significantly correlated with the error term. So this condition is known as endogeneity. Although we can also assume that maybe x1 or x2, maybe any one of them or maybe both of them may also be correlated with the error term. That condition would also be known as endogeneity. So always remember that one of the assumption in case of dynamic panel would be that your T would be small and your N would be large. Additionally, your dependent variable, the lag value of your dependent variable would be considered as an independent variable, and it would influence the dependent variable. And also the lag value of dependent variable would also be correlated with the error term, which may cause it as an endogeneity issue. So whenever there is an endogeneity issue in a model, it is known, it is used to consider the estimation method like GMM. So we need to see this paper. Here they have mentioned the lag value yit minus 1 is a function of ui. Ui is basically the error term. So because of the correlation between the lag dependent variable and error term, the least square estimates are biased. What does it mean? It means that if this is the model and we have considered it a dynamic model, and if we are going to use the lag dependent variable in the model, and we are going to estimate it using, for example, pooled OLS, using fixed effect, using random effect, using panel ARDL, and so on. If if we are going to estimate this model with these estimation technique, it is going to give us biased estimate. Always remember that we are not going to use pooled OLS, fixed effect, random effect, panel ARDL if your model has lag dependent variable as an independent variable. So it will give us bias estimate. So what is the solution if you have a model like this? What is the solution? How we can have the estimates which are bias free? So we need to consider the GMM estimation, which is basically the generalized method of movement. So in this case, we have two types of estimation. The first one is called the difference GMM, and the second one is called the system GMM. So these are the techniques which are bias free in case of dynamic panel data model. Because if we are going to use these methods for estimation of dynamic panel data model, they would give us biased estimates. So if we want unbiased estimates with dynamic panel data model, we need to use the GMM estimation, which includes the difference GMM and system GMM. So what is the difference between both of these methods and how they are applied? We have two methods, difference GMM and system. Always remember that uh, these are basically classified on the basis of certain assumptions. For example, in 2001, uh, this method was introduced. All right, was a sudden interruption of internet. I was discussing that difference GMM technique was introduced in 2001, and the system GMM technique was introduced in 2005. It was basically introduced in 2003, but it was included in Stata software in 2005. So there are certain limitations of the first method with respect to dynamic panel data modeling, while these limitations are controlled in case of system GMM. So system GMM is considered the most preferred and most you can say efficient model in case of GMM estimation. There are some other assumptions that I will discuss with you later on, but let me discuss with you some of the basic consideration that you need to understand. So what we have concluded here, we have concluded that we might have small t, we might have large n, and in that case, large n means that the n should be greater than 25, and small t means that t would be less than 25. So this would be considered small t and large n. The second consideration that we have finalized here is the inclusion of lag dependent variable as a independent variable in your model. And the third consideration that you have find out here is the endogeneity issue. So as the lag dependent variable has become the independent variable in your model, it would be it would raise the endogeneity issue, because if the independent variable is significantly correlated with the error term, this scenario is known as endogeneity. So endogeneity is the basic consideration that would require you to make estimations of your dynamic panel data model using GMM estimation, like different CMM and system GMM. Because if you are going to use the pooled OLS, fixed effect, random effect, panel ARDL, or other techniques, it would give you bias estimates. So this is the basic summary. Let me show you some other consideration that you need to understand. But before going into further detail, let me check how much time is available with us. The screen is not showing the time, but if the time is over for the session, please connect again, or join again using the same link, so that we may continue, because the session time is up to 6:20, while it is 5:40 here in Pakistan. So we can continue with another session for the remaining part. So current value of dV is significantly correlated with its parts value we have discussed. IV is significantly correlated with error term, which causes the endogeneity. In that case, we need to find an instrument variable, which is alternative to your endogenous variable, and which is also not correlated with the error term. So, the first concept that you have understood here is endogeneity. It means when an IV is when a particular IV is significantly correlated with error term, it is known as endogenous variable. So, for example, we have some variable, and one of those independent variables is significantly correlated with the error term. In that case, that particular variable would be considered as a endogenous variable. So what we need to do, we need to have some replacement of that endogenous variable. That replacement is known as instrument variable. So you need to understand what is the concept of instrument variable. So when a particular variable, is used as a replacement of endogenous variable, and that variable is also not significantly correlated with error terms, that variable is known as instrument variable. So for example, there are some variable, like, let's suppose, in case of your model, let's suppose that ROA is considered endogenous variable. It means that in your model, ROA is significantly correlated with error term. So we need to provide some replacement. Let's suppose we considered ROE as a replacement of ROA. Always remember that your instrument variable would be the replacement of your endogenous variable. You cannot consider any unrelated variable or unspecified variable which is not basically would be considered as a replacement of your endogenous variable as an instrument variable. So ROA is replaced by ROE. So you need to check whether ROE is significantly correlated with error term or not. So let's suppose this is not significantly correlated with error term. Then it would be considered as a instrument value. So this is how you can use the instrument variable. You can use another instrument variable, for example, Tobin's Q. It is another measure of profitability, and it can replace the ROA. You can use the EPS. You can use the another variable like book to market ratio, and so on. There are a lot of variables that you may find through the literature